Good afternoon. We are the Group 3 tasked to tackle the topic of conceptualizing interaction. It is the chapter 3 of the book titled Interaction Design Beyond Human-Computer Interaction. So when coming up with new ideas in the project design phase, it is important to conceptualize them in terms of what the proposed product will do. This is referred to as proof of concept. Importante yung step na to kasi dito malalaman kung feasible ba or nababagay yung idea na gustong i-add sa project or kung doable ba yung naiisip na concept dun sa project. When beginning a design project, it is important to be clear about the underlying assumptions and claims. An assumption is taking something for granted when it needs further investigation, and a claim is stating something to be true when it's still open to question. So, when proposing new ideas, di na maiiwasan na mag-stumble tayo sa assumptions and claims, be it in the project itself or the new ideas that are being added. But what's important is to get rid of these things early on and to make it clear to the user what the true purpose of the project is. By writing down assumptions and claims and then trying to defend and support them can highlight vague concepts. In doing so, poorly constructed ideas can be reformulated. In many projects, this process involves identifying human activities and interactivities that are problematic and working out how they might be improved through being supported with a different set of functions. Working through assumptions. Explaining people's assumptions and claims about why they think something might be a good idea or not enables the design team to view multiple perspectives on the problem space, and in so doing, reveals conflicting and problematic ones. When we work through assumptions, we are not only solving any differences, but also widening the scope of how we solve the problems that we can encounter in designing a project. Making clear what one's assumptions are about a problem and the claims being made about potential solutions should be carried out early on and throughout the project. Design teams also need to work out how best to conceptualize the design space. Benefits of conceptualizing. Orientation. Enables design teams to ask specific questions about how the conceptual model will be understood. Being open-minded. Prevents design teams from becoming narrowly focused early on. Having common ground allows design teams to establish a set of commonly agreed terms. Once formulated and agreed upon, a conceptual model can then become a shared blueprint, leading to a testable proof of concept. It can be represented as a textual description and/or in a diagrammatic form, depending on the lingua franca or common language used by the design team. It can be used not just by user experience designers, but also to communicate ideas to business, engineering, finance, product, and marketing units. The conceptual model is used by the design team as the basis from which they can develop more detailed and concrete aspects of the design. In doing so, design teams can produce simpler designs that match up with users' tasks, allow for faster development time, result in improved customer uptake, and needless training and customer support.
Good day, classmates and moms and dad. I'm Angel De Castro from Group 3, and today we will discuss the Chapter 3 from the provided textbook. We narrowed down the informations to keep our report short and detailed at the same time. You may ask questions by the end of our report. From problem space to design space, having a good understanding of the problem space can help inform the design space. For example, what kind of interface, behavior, functionality to provide. Before deciding upon this, it is important to develop a conceptual model. Conceptual model. A conceptual model is a high-level description of how a system is organized and operates. A conceptual model enables designers to straighten out their thinking before they start laying out their widgets, provides a working strategy and framework of general concepts and their interrelations. Components of a conceptual model, metaphors and analogies, understand what a product is for and how to use it for an activity. Concepts that people are exposed to through the product. Task domain objects, their attributes and operations, for example, saving, revisiting, and organizing. Relationships and mappings between these concepts. First steps in formulating a conceptual model. What will the users be doing when carrying out their task? How will the system support this? What kind of interface, metaphor, if any, will be appropriate? What kinds of interaction modes and styles to use? Always keep in mind, when making design decisions, how the user will understand the underlying conceptual model. Conceptual models, many kinds and ways of classifying them. The best conceptual models are often those that appear obvious and simple. The operations they support are intuitive to use. Interface metaphors. Interface designed to be similar to a physical entity but also has own properties. For example, desktop metaphor and web portals can be based on activity. Objects are combination of both, exploits user familiar knowledge, helping them to understand the unfamiliar, conjures up the essence of the unfamiliar activity, enabling users to leverage this to understand more aspects of the unfamiliar functionality. Examples of interface metaphors, conceptualizing what users are doing, for instance, surfing the web. A conceptual model instantiated at the interface, for example. The example metaphor, visualizing an operation, for instance, an icon of a shopping cart into which the user places item and also a magnifying glass icon near the search box. That means to search, and if you click on it, you will find the results of what have you been looking for.
The card metaphor. The card is a very powerful UI. Why? It has a familiar form factor. It can easily be flicked through, sorted, and themed. It structures content into meaningful chunks, similar to how paragraphs are used to chunk a set of related sentences into a distinct section. Its material properties give the appearance of the surface of paper. Like yung card metaphor, as you can see, sobrang dense na ng information niya at makikita mo na talaga kung ano yung pinaparating niya and maayos tignan, hindi siya magulo. So, yung information makukuha mo. Then, benefits of interface metaphors. Makes learning new system easier. Helps user understand the underlying conceptual model. Can be very innovative and enable the realm of computers and their applications to be made more accessible to a great diversity of users. Problems with interface metaphors. Break conventional and cultural rules. For instance, recycle bin placed on desktop can constrain designers in the way that they can conceptualize a problem space. Conflict with design principles forces users to understand only the system in terms of the metaphor. Designers can inadvertently use bad existing designs and transfer the bad parts over. Limits designers' imagination in coming up with new conceptual models. Interaction types. Instructing Instructing, issuing commands and selecting options. Conversing, interacting with a system as if having a conversation. Manipulating, interacting with objects in a virtual or physical space by manipulating them. Exploring, moving through a virtual environment or a physical space. Responding, the system initiates the interaction and the user chooses whether to respond. Instructing, number one, instructing, where users instruct a system and tell it what to do. For example, tell the time, print a file, or save a file. Yung instructing yung pag yung user yung nag-instruct dun sa like program or application kung anong dapat niyang gawin. Yung user yung mag-i-input nung dapat niyang gawin. Tapos yung program yung magpo-process nun para magkaroon ng output. Very common conceptual model underlying a diversity of devices and systems. For instance, word processor, VCRs, and vending machine. The main benefit is that instructing supports quick and efficient interaction. Good for repetitive kinds of action performed on multiple objects. Conversing. Underlying model of having a conversation with another human. Ranges from simple voice recognition, menu-driven system to more complex natural language dialogue. Examples include timetables, search engines, and advice-giving systems and help systems. Also, virtual agents, chatbots, toys, and pet robots designed to converse with you. Pros and cons of conversational model. Allows user, especially novices, to interact with a system in a way that is familiar with them. Can make them feel comfortable, at ease, and less scared. Misunderstanding can arise when the system does not know how to parse with what the user says. For example, voice assistants can misunderstand what children say.
Manipulating. This form of interaction involves manipulating objects, and it capitalizes on users' knowledge of how they do so in the physical world. Isang example ay kung saan maaari mong paglaruan ang isang digital object ayon sa iyong kagustuhan. Kung saan pwede mo itong galaw-galawin, i-zoom in at i-zoom out, piliin at pahabain ng naaayon sa iyong gusto. Human actions can also be imitated through the use of physical controllers. For example ay Nintendo Wii. Or mga gestures na ginagawa sa hangin na kadalasan mong makikita sa mga makabagong kotse. Nagagaya din dito ang galaw ng mga tao sa tulong ng physical controllers tulad ng Nintendo Wii, gaya nga na nasabi ko, o mga gestures na kadalasang makikita sa makabagong kotse. Physical toys and robots have also been embedded with technology that enables them to act and react in ways depending on whether they are squeezed, touched, or moved. Tag physical objects such as balls, bricks, or blocks that are manipulated in a physical world, for example, placed on a surface, can result in other physical and digital events occurring, such as a lever moving or a sound or animation being played. A framework that has been highly influential, originating from the early days of HCI, in guiding the design of the GUI applications or graphical user interface applications, is direct manipulation. Termed and coined by Schneiderman in 1983, it proposes that digital objects be designed at the interface level so that they can be interacted with in ways that are now analogous to how physical objects in the physical world are manipulated. Ibig sabihin dito ay, pinopropose ng direct manipulation na ang mga objects daw ay dapat i-design sa interface level upang maging malapit sa physical object na counterpart nito. In doing so, direct manipulation interfaces are assumed to enable users to feel that they are directly controlling the digital objects represented by the computer. The three core principles are as follows. First is continuous representation of the objects and actions of interest. Second is rapid, reversible incremental actions with immediate feedback about the object of interest. Third and last is physical actions and button pressing instead of issuing commands with complex syntax. According to these principles, an object on the screen remains visible while a user performs physical actions on it. And any actions performed on it are immediately visible. For example, a user can move a file by dragging an icon that represents it from one part of the desktop to another. Here are the benefits of direct manipulation, including the following. Helping beginners learn basic functionality rapidly, or mas mabilis na natututo ang mga bagong users ng iba't ibang function. Enabling experienced users to work rapidly on a wide range of tasks. Allowing infrequent users to remember how to carry out operations over time. Preventing the need for error messages, except rarely. Showing users immediately how their actions are furthering their goals. Reducing users' experience of anxiety. Helping users gain confidence and mastery and feel in control. Along with its benefits, there are also drawbacks. First, some people will take the metaphor of direct manipulation too literally. Not all tasks can be described by objects and not all actions can be done directly. Some tasks are better achieved through delegating, for example, spell checking. Some can become screen space gobblers. Moving a cursor using a mouse or touchpad can be slower than pressing function keys to do the same. Exploring. It involves moving through virtual or physical environments. Users can explore aspects of a virtual 3D environment. Physical environments can also be embedded with sensors that when detected, the presence of someone will trigger digital or physical events to happen. Many examples of virtual environments including cities, parks, buildings, rooms, and datasets enables users to fly over them and zoom in and out of different parts. Tinutukoy nito ang malayong paglalayag sa isang environment kung saan maaari kang makipag-interact sa mga users sa kanyang paligid. May kakayahan siyang gawin ang mga aksyon na kadalasang di magagawa sa totoong mundo. May mga environments din na may sensors kung saan maaari kang makipag-interact upang makapag-trigger ng mga actions. Exploration involves users moving through virtual or physical environments. For example, users can explore aspects of a virtual 3D environment, such as the interior of a building. Physical environments can also be embedded with sensing technologies that when they detect the presence of someone or certain body movements, respond by triggering certain digital or physical events. The basic idea is to enable people to navigate through exiting spaces. Other virtual environments that have been built include worlds that are larger than life, enabling people to move around them, experiencing things that are normally impossible or invisible to the eye. The first picture shows a cave that enables the user to stand near a huge insect, for example a beetle, be swallowed, and end up in its abdomen.
The second picture shows the NCSA's cave being used by a scientist to move through 3D visualizations of the datasets.
Responding. This mode of interaction involves the system taking the initiative to alert, describe, or show the user something that it thinks is one of the interests or relevance to the context user is presently in. It can do this through detecting the location or presence of someone in a vicinity and notifying them about it on their phone or watch. Smartphones and wearable devices are becoming increasingly proactive in initiating user interaction in this way, rather than waiting the user to ask, command, explore, or manipulate. Just like for example. An example is a fitness tracker that notifies the user of a milestone they have reached for a given activity. Having walked 10,000 steps in a day, the fitness tracker does this automatically without any requests made by the user. The user responds by looking at the notification on their screen or listening to an audio announcement that is made. Potential cons of system-initiated notifications. For some people, this kind of system-initiated interaction where additional information is provided which has not been requested. It might get a bit tiresome or frustrating, especially if the system gets it wrong. The challenge is knowing when the user will find it useful and interesting and how much and what kind of contextual information to provide without overwhelming or annoying them. Also, it needs to know what to do when it gets wrong. Just like for example, if it thinks that the dog is a teddy bear, will it apologize? Will the user be able to correct it and tell it what the photo actually is? Or will the system be giving a second chance? Choosing an interaction type. Direct manipulation is good for doing the type of task, for example, designing, drawing, flying, driving, and sizing windows. Issuing instruction is good for repetitive tasks, just like for example, spell checking and file management. Having a conversation is good for certain services, for instance, finding information or requesting music. Having hybrid conceptual models are good for supporting multiple ways of carrying out the same actions. The difference between interaction type and interface styles. Interaction type. It is a description of what the user is doing when interacting with a system, just like for example, instructing, talking, browsing, or responding. While interface style is the kind of interface used to support the interaction, for instance, command, menu-based, gesture, or voice. And these are the other kinds of interface styles, and they are command, speech, data entry, form fill-in, query, graphical, web, pen, augmented reality, and gesture. Paradigm. Paradigm is the inspiration for a conceptual model. It is a general approach adopted by a community for carrying out a research. In the 1980s, the prevailing paradigm in human-computer interaction was how to design user-centered application for the desktop computer. It is a shared assumption, concept, values, and practices. Just like for example desktop ubiquitous computing in the wild. Examples of new paradigm in human-computer interaction. Ubiquitous computing, pervasive computing, wearable computing, and Internet of Things.
A vision is a future that frames research and development in interaction design. This invites people to imagine what life will be like in 10, 15, or 20 years' time. For example, Apple's 1987 Knowledge Navigator, smart cities, smart health, and human-centered AI. It provides concrete scenarios of how society can use the next generation of imagined technologies, while also raising ethical questions such as privacy and trust. Over the past 30 years, numerous theories have been imported into human-computer interaction, providing a means of analyzing and predicting the performance of users, carrying out tasks for specific types of computer interfaces and systems. These have been primarily cognitive, social, affective, and organizational in origin. For example, cognitive theories about human memory were used in the 1980s to determine the best ways of representing operations. One of the main benefits of applying such theories in interaction design is to help identify factors relevant to the design and evaluation of interactive products. The term model has also been used more generally in interaction design to describe some aspect of human behavior or human-computer interaction. Typically, it depicts how the core features and processes underlying a phenomenon are structured and related to one another. It is usually abstracted from a theory coming from a contributing discipline like psychology. It enables designers to predict and evaluate alternative designs. Numerous frameworks have been introduced in interaction design to help designers constrain and scope the user experience for which they are designing. In contrast to a model, a framework offers advice to designers as to what to design or look for. This can come in a variety of forms including steps, questions, concepts, challenges, principles, tactics, and dimensions. Frameworks, like models, have been traditionally been based on theories of human behavior, but they are increasingly being developed from the experience of actual design practice and the findings arising from user studies. Many frameworks have been published in the interaction design literature, covering different aspects of the user experience and a diversity of application areas. One of the classic examples of a conceptual framework that has been highly influential is Don Norman's framework of the relationship between the design of a conceptual model and the user's understanding of it. The framework comprises three interacting components: the designer's model, the system image, and the user's model. The framework makes explicit the relationship between how a system should function, how it is presented to the users, and how it is understood by them. To summarize, paradigms, visions, theories, models, and frameworks are not mutually exclusive, but rather they overlap in their way of conceptualizing the problem and design space, varying in their level of rigor, abstraction, and purpose. Paradigms are overarching approaches that comprise a set of accepted practices and framing of questions and phenomena to observe. Visions are scenarios of the future that set up challenges, inspirations, and questions for interaction design, research, and technology development. Theories tend to be comprehensive, explaining human-computer interactions. Models are an abstraction that simplifies some aspect of human-computer interaction, providing a basis for designing and evaluating systems. And frameworks provide a set of core concepts, questions, or principles to consider when designing.